Hello everyone, good morning everybody. Myself Sunil Pawar from New Catholic Mission Higher Secondary School welcomes you back for the new video session of 10th class. Today we are going to start the new chapter, that is the chapter number 12 from the physics portion, that is the electricity. Okay, as you know that in this modern period of life, or in this present scenario or the present era, we can't imagine life without the electricity. As we know that this electricity is the most convenient, most efficient and most easily usable form of the energy. Okay, so in today's discussion we will talk about the different aspect of the electricity, or what we call that is the electrical energy. Okay, it makes our life is very easy, right? So now we can see that this electricity is an essential part of life in today's world, and it is a controllable and convenient form of energy. This is the most important facts about this one thing. It is controllable, just like that some form of energy cannot be controlled and they cannot be conveniently usable. Okay, so there is some inconvenience in their use, just like the solar energy and this one thing. Okay, but it can be used very conveniently. So electricity is being used in almost every sector of modern society, like household activities, okay, commercial, transport and industry. Okay, and this all such things make our life faster and easier. As I told you, you can't imagine your day-to-day life without the use of this electricity. Okay, you can see in your kitchen, from mixer to microwave, from this induction to the fridge, deep freezer, everything is working with the electricity. Okay, this all industries are purely based on this electric power. Okay, the modernization is purely based on this electrical energy. Okay, so first of all we are going to discuss about the electric charges. What is the charge and what is the electric charge? Okay, so it is like mass. The charge is the fundamental property of matter. Okay, you know that a charge is a physical entity which is defined by excess or deficiency of the electrons on a body. You know that an atom is a neutral one. Okay, but when it donates or receives the electrons, then it becomes a charge structure. Clear? So till that it will not either loses or gain the electron, it is a neutral entity, but when it gain or lose the electron, then it will become a charge structure. Clear? So a body is said to be negatively charged if it gain the electron. Okay, as I told you, how it become charged in nature, either by gaining the electron or by losing the electron. Clear? When this particle will gain the electron, then surely electron is negatively charged, you know very well. So it will consider as the negatively charged body, or we call it the negatively charged. Okay, and when it will loses an electron, then proton become more than the negative charges. So that's why it is called as the positively charged. Clear? A negatively charged body can be observed by or obtained by rubbing an ebonite rod with the fur. Okay, this flannen or this fur, when you rub this ebonite rod, then it will charge with the negative charges. Clear? And when we rub a glass rod with the silk cloth, then it acquires the positive charges. Clear? So such body which is having positive charges in excess is called as positively charged, and which is the negatively charged is called as negative charges. Clear? So this is basic fact. And the SI unit of the electric charge is coulomb. Remember, this is also the SI unit of electric current too. Clear? So remember this one thing. Sorry, this is the unit of electric charge, coulomb. Later we will discuss that what is the coulomb. Okay, now the total charge acquired by a body is an integral multiple of the magnitude of the charge on a single electron. Okay, and this principle is called as the quantization of the charges. Clear? That means whatever the number of electron or the charges is gained by this particle, that is considered the magnitude of this one. Okay, now it is just the multiple of the electron. Clear? If you want to know about the magnitude of that particle, then you have to multiply the quantity of the electrons. Clear? And the magnitude of charge on one electron, that is minus 1.6 into 10 to the power minus 19 coulomb. Remember these values. Okay, it is also helpful for your numerical portion too. Clear? So what is the total charges of an electron? That is minus 1.6 into 10 to the power minus 19 coulomb. Okay, and what is the charges on an electron? If you want to know about the number of electron is there, then you just multiply, that is the Ne. Okay, what is the N? The number of electron. Ne is the charges on the electron. So the number of electron is multiplied by the 1.6 into 10 to the power minus 19 coulomb. Then you will get the magnitude of the total charges. Clear? Similarly, if you want to know about the magnitude of the charges on one electron, then it is just 1.6, but on the place of negative it is positive 1. Okay, remember, because you know that protons are positively charged particles. So here is 1.6 into 10 to the power minus 19 coulomb is positive charge. So this is the only difference between the proton and electron. Electrons consisting minus 1.6 into 10 to the power minus 19 coulomb, while the proton is having plus 1.6 into 10 to the power minus 19 coulomb. Clear? Now, then here we are going to discuss the properties of the charges. As you know that, just like the magnetic poles, okay, similar charges repel each other and the unlike charges attract each other. Okay, this is the basic fact about the charges. Okay, and the force between the two charges varies directly as the product of the two charges and the inversely as the square of the distance between both the charges. Okay, suppose that there are two charges Q1 and Q2. Okay, and you want to know about the force of attraction or repulsion between them. Okay, then it will be inversely proportional to the which one thing, the product of these charges as well the square of the distance between these two. Okay, so you can see that this force is inversely proportional to the product of the charges and this square of the distance between two. Okay, because of this what do you say, this is the PPT, it is just changed, it is not R2, it is the R square. Okay, or when we replace this sign with the help of this constant. Okay, this is the K is the constant, universal constant. So it will be F is equal to K into Q1 into Q2 upon R square. Again I am repeating, this R square is the distance between the square of the distance between the two particles. Remember this thing. Okay, and the SI unit of the charge is the coulomb, as we discussed earlier. So now here we want to go to clear that what is the coulomb. So 1 coulomb is equal to 1 ampere into 1 second, that is the 1 AS. A stands for the ampere and S stands for the second. Clear? So 1 coulomb is the product of 1 ampere and 1 second. Clear? So here the definitely the quantity of charge which flows through a circuit when 1 ampere of current flows through it in 1 second is known as 1 coulomb charges. Okay, if you want to define the 1 coulomb charges, if you want to know about the quantity of the 1 coulomb charges, then if 1 ampere current is passes through a unit area in 1 second, then it will be equal to the 1 coulomb. Clear? Remember this fact, what is a coulomb and what is the quality of this one thing. Okay, then here we are going to discuss the second part of this portion, that is the electric current. Okay, simply if you remember, then when we talk about the electric current, then simply we say that the movement, okay, or the flow of the negatively charged particles is called as electric current. Simply, okay, just try to learn this one thing. The flow of electric charges is known as the electric current, and this electric current is carried by moving electrons through a conductor. Okay, you know that electrons are negatively charged particles. So when they move from one electrode to the next electrode or one point to the another point of the conductor, that will be considered as the flow of charges, or it is called the flow of electric current, right. Now, by convention, electric current flows in the opposite direction to the movement of electron. Remember, with the help of this diagram we will learn this one thing. What will be the direction of the flow of electric current, and what is the flow of the electric charges, clear, electron, direction of the electron, clear. So, this electric current is defined as the rate of flow of charge through any cross section of a conductor in unit time. If you want to define that, then what amount of electric charges is passes through the unit area, which area? The cross section area in 1 second, or the unit time, that is called as electric current, clear. So, if you want to express this electric current, then it is denoted by the I in the italics, okay. This I is represented this one, and this electric current is expressed by the rate of flow of electric charges, and the rate of flow means the amount of charge flowing through a particular area in unit time. What is this particular area? This particular area is actually the cross section area of that conductor, okay. And what is this unit time? This unit time may vary according to the second, millisecond or minute or whatever is there, but basically in general when we talk about the unit time, then it is none other than the 1 second, clear. Okay, just come to see this diagram. Okay, here you can see that these two terminals of the cell is there. This is the positive terminal and this is the negative terminal, clear. You can see that when sorry, when you talk about the flow of positive charges, that will move from anode to cathode, clear. And when this flow of electron, then it is from cathode to anode, clear. So, remember, just like that earlier we discussed what is the basic fact. Always the direction of the electric current is just opposite in the direction of the flow of electric the electrons, clear. So, these electrons are moving from cathode to anode, then what is the direction of the electric current? It will move from anode to cathode, okay. The conventional flow of the electric charges is shown with the help of this diagram. So, remember, there is the opposite direction of flow of electric current and the electric charges or the electrons, clear. Electrons always move from negative terminal to positive, and electric current will always flow from positive terminal to negative terminal, remember this one, okay. So, now if a net electric charge, what we call it, that is the Q, flow through a cross section of a conductor in time t, then this electric current I is equal to Q upon T. What is this Q? Q is the net charge. If you want to find out this Q, then multiply the number of electron with the help of the electron numbers, okay. So, this way you will get this Ne upon T. T is the second here only, clear. Now, where I is the electric current, Q is the net charge and the T is the time in second, clear. Now, and here we are going to discuss the SI unit of the electric charge and the current, clear. As we talked earlier, what is the SI unit of the electric charge? It is the coulomb, okay. And 1 coulomb is nearly equal to 6.24 into 10 to the power 18 electrons, remember, okay. What is the value of 1 coulomb? 6.24 into 10 to the power 18 electrons, okay. And the SI unit of electric current is ampere. It is denoted with the help of capital A, okay. And this unit is actually named in the honor of French scientist, that is the Andre Marie Ampere, okay. And this ampere is the flow of electric charge through a surface at the rate of 1 coulomb per second, right. Remember this one thing. What is the ampere? If you want to know about the ampere, then you have to find out the flow of electric charges through a surface at the rate of 1 coulomb per second, that will equal to 1 ampere, okay. That means 1 coulomb charges should passes through one surface in a second, then it will be equal to 1 ampere, okay. And this means if 1 coulomb of electric charge flows through a cross section for 1 second, it would be equal to 1 ampere, remember this one thing. And 1 ampere is equal to 1 coulomb per second. Simply if you want to define this ampere, then it is nothing special, it is just 1 coulomb per second. What is this coulomb? This is the unit of charges. Okay. Now here we are going to discuss this small units of electric current. Okay. This ampere is the normal one. If you want to discuss about the smaller unit, that is the milliampere and the microampere. Okay. 1 milliampere is equal to 10 to the power minus 3 ampere. Okay. And 1 microampere is equal to 10 to the power minus 6 ampere. Remember this one thing. Okay. Or you can say that 1 ampere is equal to 1 upon 1000 part of an ampere. 1 milliampere is equal to 1 upon 1000 part of an ampere, and microampere is equal to 1 upon 10,000 part of an ampere. Okay. So that's why theoretically this one is given here. Okay. And just to know about the value of the ampere in a circuit, okay, or the strength of the electric current in a circuit, we always use an instrument that is called as the ammeter. Okay. And remember, this ammeter is always applied in a series condition. Okay. When you fix this instrument ammeter in the circuit, that will always be there in the form of which pattern? That is the series pattern, right? Now then here we are going to discuss the electric potential and the electric potential differences. Clear? So first of all, what is the electric potential? The amount of electric potential energy at a point is called the electric potential. That means at the point, what is the difference between the 2 points of the electric charges, that is considered the electric potential. Okay. It is defined as the amount of work done when a unit positive charge is moved from infinity to a point in an electric field. Okay. Suppose that there is a charge, okay, a bunch of charges, and when you move positive which one thing charge, okay, from infinity to that certain point, then what amount of work is actually performed or the done, that is equal to the electric potential. Clear? It is in the form of it will be either attracted or repelled. Okay. So what is the force will apply? Now the potential difference. The difference in the amount of electric potential energy between the 2 points in an electric circuit is called the electric potential difference. Remember, potential difference and the electric potential. When you talk about the electric potential, then you know 1 point. Okay. And when you talk about the electrical potential difference, then you have to take the 2 different points in a circuit, okay, in a conductor, right? Now, so this electric potential difference is known as the voltage, right? It is denoted by the capital V, and which is equal to the amount of work done to move the unit charge between the 2 points against the static electric field. Okay. So what is the condition? This electric field should be static in nature, and when you move this charge from that in the particular direction for the particular distance. Clear? So therefore the voltage is equal to work done upon charges. Clear? Or this voltage of electric potential difference is denoted by capital V. So therefore V is equal to W upon Q. What is W? W is the work done, and what is the Q? That is the quantity of the charges, or you can simply say that NE. Clear? Now, so here the SI unit of electric potential difference is volt, and as I told you earlier, it is denoted by V. So this is named in the honor of an Italian physicist, that is the Alessandro Volta. Okay. So this is the name of the scientist who discovered this thing, and his name is honor only. We use this unit for the potential difference as a volt, and it is denoted by capital V. Remember this fact. Okay. Now moving forward, so similarly we know that this joule is the unit of work and the coulomb is the unit of charge. Okay. We learn that what is 1 volt? 1 volt is equal to work done upon charges. Okay. So what is the SI unit of work done? That is the joule. And what is the SI unit of the charges? That is the coulomb. Okay. So 1 volt of electric potential difference is equal to the 1 joule of work to be done to move charge of 1 coulomb from one point to another in an electric circuit. Okay. So if you want to find out, if you want to define this 1 volt, then how much work you need to perform? that is equal to 1 joule of work is need to be done when you move a charge of 1 coulomb from one point to another point in a static electric current. Clear? Remember this one thing. Okay. So therefore 1 volt is equal to 1 joule per coulomb, or simply you can say that 1 joule coulomb to the power minus 1. Okay. And here again similarly, if you want to talk about the smaller unit of the volt, then simply just like the ampere, here is the millivolt and the microvolt. Millivolt is equal to 10 to the power minus 3 volt, and microvolt is equal to 10 to the power minus 6 volt. Okay. But here we are having such bigger large units also. So here these two units are there. One is the kilovolt, okay, and second is the megavolt. Clear? 1 kilovolt is equal to, remember there is difference between the volt and the watt. Okay. Watt we use for the power, okay, and volt we use for the potential difference. Remember this one thing. So this power is actually denoted by the capital W, okay, and it is the watt, W-A-T-T, okay, and this potential difference is the volt, that is the V-O-L-T. It is denoted by capital V. Don't be confused with these two different units. Okay. So now 1 kilovolt is equal to 10 to the power 3 volt, and 1 megavolt is equal to 10 to the power 6 volt. Okay. So here we consider the SI units, also they are smaller unit as well as the larger units too. Okay. Now then here just like that we learn that the instrument which used to measure the potential of the electric current, it was named as ammeter. Similarly, the instrument which we use to measure the potential difference between the 2 points of a conductor in a circuit is considered as the voltmeter. And remember, this voltmeter is always applied in a parallel way. Okay, remember this one thing, it always applies in a parallel way whenever you perform any experiment. Okay, and that is the verification of the this Ohm's law. Okay, or whenever you apply this ammeter and voltmeter in a circuit, then please remember this thing in your mind. This ammeter is always applied in a series and voltmeter is always applied in a parallel way. Okay, so what is the series and parallel arrangement? We will discuss later. Clear? Now, so the one more instrument, that is called the galvanometer, and it is the device to detect the current in an electric circuit as well as the direction of the electric current too. Okay, so this is the galvanometer. Now here we are going to discuss the electric circuit. What is the circuit? So a closed and continuous path through which the electric current flows is known as the electric circuit. Okay, and to complete a electric circuit you needed the various components. Okay, and what are these components? First of all, a source of electric current. It is none other than a cell or a battery. Clear? Then a load, one who used to consume this electric current. It is compulsory. Okay, it may be in the form of a bulb, it may be in the form of any resistor, any electrical appliance or whatever is there. Okay, and a switch, or what you call the key to switch on and switch off the circuit. Okay, as well a fuse to manage and maintain the which one thing, the this one thing, the protection of the circuit. Okay, and these all things should be connected with the help of copper wire. Basically always we use the copper wire because it is easily available as well as it is a good conductor of electricity. Now here we are talking about the two different types of the electric circuit. Okay, so this is two type, one is the closed circuit and second is the open circuit. Clear? What is the closed circuit? When the key is closed, then the circuit is called the closed circuit. It means what? That the current would flow through the circuit to operate the device. Okay, remember it sounds somewhat differently. When we say that the circuit is closed, that means it allowed to run the electric current or to complete the circuit, this point to point. Okay, while when you talk about the open circuit, it means that it is discontinued in nature, okay, and it is not actually allowing to complete the circuit. So remember, the word is closed circuit, but it sounds differently. When the circuit is closed, then only the charges can flow. Okay. Now, moving forward, this two diagrams are given. You can see that this is the open circuit and this is the closed circuit. Okay. As I told you, this is the source of electric current, that is the battery. This is the load, what we call here bulb. Okay. This is the key. Okay. This is the one way key only. Okay. So when you plug in the key, then this will complete the circuit and this bulb will start to glow, the closed circuit. Okay. And when you remove the key or unplug the key, then this bulb will stop glowing because now the circuit become discontinued. Okay. And this is the open circuit. Okay. So now some symbols are given here to learn about the or to represent them in the open and closed circuit. Okay. So this is the single positive and negative terminal. Okay. Then it is an electric cell. When more than one electric cell connected in a series, then it is considered as the battery, or it is also considered a combination of this one. Okay. Remember, one cell is equal to, its output is equal to 1.5 volt. Okay. And whenever more than one electric cells are displayed there in the combination, then just add them, it will give you the output of this one. Okay. This is the plug key, which is open, this is closed. Okay. This one shows actually the joint of a wire in a circuit. Clear? And here you can see that two wires are crossing each other, but this loop is showing that it is not connected, it is just passing above each other. Okay. Now this is the electric bulb. The two positions are there. When there is the linings around it, then it is the glowing, or this, if it is colorful, then it shows the electric this light energy too. It shows the resistance, it is denoted by the capital R, and it is the permanent or the constant resistance, it is not variable. Okay. While if you show like this one thing, then this is a symbol of the variable resistors, or it is also the symbol of rheostat. Okay. Later we will discuss that. What is the rheostat? It is the device which used to control the resistance of the circuit. Okay. This is the ammeter having the two terminal positive and negative one. This is the voltmeter, again having the two terminal positive and negative one. Positive terminal is always connected with the positive terminal of the cell or the battery, and negative with the negative side. Clear? This is the galvanometer, which is represented with the capital G, again having the positive and negative terminal. Okay. So now we are moving towards the next point, that is the Ohm's law. Okay. So this Ohm's law is actually given by the German physicist George Simon Ohm. Okay. So this George Simon Ohm has given a relationship between the current and flowing in a metallic wire and the potential difference V across the terminal. Okay. So simply this Ohm's law is nothing special. It is just a relationship between these two, I and V. What is the I? The electric current which flows through a circuit or the conductor. And what is the V? V is the potential difference at the two different points of a circuit. Clear? Now, so what is the Ohm's law? Just remember this statement. It is there for 1 mark or the numerical values 2. Clear? So what is this Ohm's law? The electric current flowing through a conductor is directly proportional to the potential difference, okay, applied across its end, and providing the physical condition remains constant. So V is directly proportional to I. Remember this one thing. Clear? So when we denoted it this one thing, then this expression is there, V is directly proportional to I. Okay. This proportion sign can be removed with the help of this constant R. Is R is equal to resistance. So V is equal to Ri, or if you want to find out I, then I is equal to V upon R. You want to find out R, then R is equal to V upon I. Okay. So if this I is constant, then this given temperature and called the resistance. Clear? Remember, for this one thing is quite compulsory. the physical condition of the circuit should be remain constant. That means the temperature, then the length of the conductor. So where R is the constant, and as I told you, it is compulsory for the Ohm's law, that is the stable physical condition. It is the specific condition there. If the physical condition remain constant, then only these conditions will be applied, or this law can be applied, that is V is directly proportional to I, okay, or V is equal to IR. Clear? Now it is clear that the current is inversely proportional to the resistance, okay, now, and directly proportional to the potential difference. Now here this V and I graph is shown here. This V and I graph is nothing special, okay. By taking this two axes X and Y, okay, this vertical axis is Y, in which we are taking representing the potential difference V, and X axis taking as the electric current I, okay. So when you place this value, then you can see that there is a straight line in the form of a slope is observed, and it represented actually the V and I graph. It is called as the VI graph. And always remember, whenever you place the whenever you put the value for the volt and the ampere, okay, graphically for any circuit, and its condition is constant, then you will get always a constant line with the specific slope there only, okay. So remember, this VI graph is denoting only this much, nothing is special. Clear? Now here we are moving forward to learn one more term, that is called as the resistance, okay. Simply, what is the resistance? Resistance means an obstacle, okay. Resistance means an interference. Simply, it is the literal meaning, okay. So this is the property of the conductor which resists the flow of the electric current through it. That means this is the nature of the matter or the substance, okay, who influence the flow of free electric charges through it, okay, and this is called as resistance. The obstacles which develop by the matter of the conductor for the free flow of the electric charge is called as resistance. Clear? And its unit is ohm, and is denoted by this word letter Q or this symbol, okay. Now, so what is 1 ohm? 1 ohm of resistance is equal to the flow of 1 ampere of current through a conductor between 2 points having a potential difference of 1 volt, okay. That means simply 1 ohm is equal to 1 volt upon 1 ampere, nothing is special. Remember this one thing. Clear? So for the expression of this Ohm's law, it is obvious that the electric current through a resistor is inversely proportional to the resistance, okay, and this means that the electric current will decreases with an increase in the resistance and vice versa. As you know that these are inversely proportional, okay. So if the V will increases, then surely I will decreases, or the I will increases, then the V will decreases there only, okay. Now sorry, resistance will decreases, okay. Otherwise there is a direct relation between the V and I. Now this resistance is a property of the conductor due to which it resists the flow of the electric current through it, okay. And a component that is used to resist the flow of electric current in a circuit is called the resistor, okay. It may be in the form of the load, right. Now, so in practical application, these resistors are used to increase or decrease the electric current to maintain the quantity of these charges there only. Clear? These variable resistance are there, which is help to regulate the current by increasing or decreasing the resistance, okay. And the instrument which we use, or the device which we use, is called as the rheostat, okay. It is also called, considered the variable resistance too. Now just try to learn that what is the cause of the resistance in the conductor. Actually know that the flow of electron in a conductor is electric current, free flow, okay. And these positive particles of conductor create hindrance to the flow of electron because of the attraction. You know that protons are positively charged and the electrons are negatively charged, and you know that what is the electric current? The free flow of the negatively charged particles, okay. So when this passes through this path, then these protons are there which is positively charged in nature, because of their attraction force toward the negatively charged particles, they create an obstacle for the free flow of these charges. That's why it is the reason behind the development of a resistance. Clear? So here some factors are there on which the resistance of the conductor is depends, or some factors are there who is responsible to influence the resistance of the conductor. Clear? One of that is the nature of the material. Okay, as you know that there are three type of conductors. One is good conductor and one is bad conductor, and third is the semiconductor. Okay, basically all these metals are good conductor, right? And the second is one who is the bad conductor, they like this plastic and this one. No? So it is called as the insulator. This plastic is one of the best example of this insulator. Clear? Because they are not having any free electron to flow through this one thing, that doesn't allow to pass them. Clear? Now then here we come to discuss the length of the conductor. Okay, the length of the conductor is directly proportional to the resistance of the conductor. Greater the length, higher the resistance. Okay, suppose you are having a wire of two wires of same weight, but there is difference in the length. Clear? So greater the length, higher the resistance will be offered by it. Okay, and less in the length, surely the resistance will be less in nature. So remember, R is directly proportional to the length of the conductor. Then the area of cross section. Clear? So there is a relation, that is the inverse proportion. Okay, the area of the cross section is the resistance is inversely proportionate to the area of the cross section. Okay, now so remember this fact. Then next one thing, so with this two, the proportionally constant, it is we come to know that this rho is equal to RAI. What is the R? Resistance. What is A? Ampere. And what is I? That is the electric current. Clear? Now, so the SI unit of the resistivity, so since the SI unit of the resistance is ohm, so SI unit of area is meter square and SI unit of the length is meter. So that's why the SI unit of the resistivity is ohm meter. Okay, remember this one thing. What is the SI unit of resistivity? That is the ohm meter. Okay, now we are just trying to learn the definition of the resistivity. It is the resistance offered by a cube of a material of side 1 meter. Okay, remember what is the resistivity? The resistance offered by a cube of a material of side 1 meter when current flows perpendicular to its opposite faces. Okay, that is called as resistivity, and its unit is ohm meter. Right? Now, so this resistance is also known as the specific resistance, and you know that each and every material or the conductor has its different specific resistance. Clear? Now, the material having the resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter, these are considered as the good conductor, while as you know that silver is the best conductor. Silver has the resistivity which is equal to 1.60 into 10 to the power 8 ohm meter, and the copper has the resistance equal to the 1.62 into 10 to the power minus 8 ohm meter. Okay, while if you observe the glass and the rubber, they are the good insulator because they are having the resistivity in between 10 to the power minus 8 to 12 ohm meter. Okay, so remember this one thing. This resistivity of material is also varies with the temperature. So there is also a relation with the resistance in the temperature. Higher the temperature, greater the resistance will be. So there is a direct relation between the temperature and this one thing. Okay, you know about the superconductor or the superconductivity. Okay, as you know that if there is a direct relation between the resistance and the temperature. Okay, if the temperature will gradually decreases, okay, then what happen? The resistance will also decreases. Okay, so once upon a time there will be a point will observe temperature, okay, where this resistance will be exactly or absolutely zero in nature. Okay. So at this time this conductor is called as which one thing? Superconductor. Okay. This temperature is called as transitional temperature, and this conductivity is called as superconductivity. Remember, superconductor, superconductivity, and the which one thing? That is the transitional temperature. Okay. Each and every substance has a specific temperature on which it will lose its resistance, right? And this one is basically used to make more sensitive electronic devices to transfer the data especially, right? Now here we are moving the combination of the resistors. Okay, actually there are three type of combination. One is the series combination, second is the parallel combination, and third is the mixed combination of resistor. If you observe that when we talk about the resistance in a series or the series resistance, then what happened, whatever the number of resistor is there, when they arrange end to end, okay, that means see that here these three resistors are there, R1, R2 and R3, okay, and in this circuit they arrange in between the 2 point A and B. Okay, so when the one point of R1 is attached with A, but the second is attached with the R2, R2 is attached with R3 and R3 is attached with B. Okay, so this is the series arrangement of the resistance, clear? But when we arrange this resistance in the series, then they will offer such a great resistance, okay, and this resistance is always equal to the sum total of all resistors who applied in the series, clear? Remember this one thing. While when we so what is the total resistance of the series resistance? It is equal to the sum total. Likewise here it is given that R is equal to R1 plus R2 plus R3 dash dash dash. That means whatever the number of the resistors, you have to add their value, you will get the total resistance of the circuit or the series one, clear? Now when we talk about the resistors in the parallel one, okay, then you can see that all these resistors, all three resistors attached with the same point A and B, okay, and this arrangement is called as the parallel arrangement of this one thing, right? And in this one, if you observe that, then what is the total resistance of this one of the circuit? That is 1 upon Rp. P stands for the parallel one and R stands for the resistance, clear? So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. What is this R1, R2, R3? The different three resistance which offer by these three resistors, okay. So when you want to find out the total resistance of the circuit when these resistors are actually arranged in a parallel fashion, okay, so that is like this one thing, this formula should be applied there, okay, and we can find out this thing, clear? Now then here we are going to discuss one more type of resistance, okay, that is the mixed combination of the resistance. Here you can see that these two resistors are in the parallel one, these two are in the parallel one, but when you compare this circuit or when you observe this circuit, then this two small circuit part of this this circuit, so that's why this arrangement is called as, these two is in the series and these two are in the parallel one. So there is a combination of two type of arrangement. One is which one? Right, one is series arrangement and second is the parallel one. That's why we call it the mixed combination of the resistor, okay, and this combination is actually also called as the complex circuit, okay. And what is the purpose of arranging like this one thing? Just to obtain a suitable resistance for the circuit, okay. And you remember that your all the devices at your home, okay, or this home circuit is basic, or the domestic circuit is purely based on this parallel combination of the devices or the resistors. Remember this one thing, just to minimize the total resistance of the circuit, okay. Now moving forward, that is the heating effect of the electric current. As I told you, this electric charges when flow, then they were actually obstructed by the material, okay, and it is responsible for developing the heat energy, okay. So when the electric current is supplied to a purely resistive conductor, the energy of electric current is dissipated entirely in the form of heat, and as a result resistors get heated, okay, and the heating of resistors because of the dissipation of the electrical energy is commonly known as the heating effect of the electric current, okay. So you know that when you pass the electric current through a device for a long period of time, metallic, na, then you can see that it become hot in nature, okay, and in your day-to-day life you apply so many applications of this heating effect of the electric current. Right now, some examples which we can see that with the help of this electrical energy when supplied to the electric bulb, okay, its filament get heated, okay, as you know that this filament is all of tungsten in nature, and if you observe that bulb, I am not talking about the CFL and the LED, okay, I am talking about the bulb, okay. So in which you can see that a filament is there, okay, and this filament is made up of which thing, tungsten, okay, and you can also see that this very fine tungsten wire filament is spirally arranged. What is the reason behind it? As you discussed in the previous point, that the resistance of the conductor is directly proportional to the length of the conductor. So that's why just to increase the resistance of the conductor, we are increasing its length, okay, we make it much more thinner in nature and we make it spirally, okay. So this is the basic fact now, and this temperature is this heating effect reaches up to certain amount that it will start to glow by releasing the light energy, okay. Then the cause of heating effect of the electric current. So this electric current generates the heat to overcome the resistance offered by the conductor through which it passes, okay, and here higher the resistance, the electric current will be generated higher amount of heat, okay. The generation of the heat by electric current while passing through a conductor is an what the inevitable consequences, okay, and this heating effect is used in many appliances. Likewise, electric iron, electric heater, immersion rods, okay, electric geyser, all these appliances actually work with the same one, okay. So just to find out the total amount of heat energy which generated by the passing of electric current, okay, a scientist named as the Joule, okay, has given a law of heating that is called as Joule's law of heating, okay. Remember this one, this is H is equal to Ri square, okay. It is actually very important just to calculate the numerical values of the different questions too, okay. So now what is this one? Just let an electric current I which is flowing through a resistors having the resistance R, okay. So the potential difference through the resistor is V. So you are having three value I, R and V, and this Q, what is the Q? Q is the number of the charges which passes through it, and what is this T? T is the time which allow to pass the current, clear. So when you want to find out the work done to moving this charge, that is W is equal to VQ. What is the V? Potential difference. What is the Q? Q is the total number of the charges which passes through this one thing, clear. So since this charge Q flows through the circuit for time T, therefore power input to the circuit can be learned with the help of this equation. P is equal to WT. What is W? W is the work done, and what is the T? T is the total time is taken, okay. So here this I is equal to QT, I is equal to QT means what? Q is the number of charges and T is the time in the seconds, clear. So you can see that P is equal to VI, okay. So since the electric energy is supplied for time, thus after multiplying both sides of the equation, by this time you will get PT is equal to VTI, okay. So that's why we are having for the steady current I is always equal for both the two sides. So we will have this H is equal to VIT, or V is equal to, we know that according to the Ohm's law, V is equal to IR. Okay, so this V is replaced by IR. So this here we are having which one thing? H is equal to I square RT. So if you want to find out the total amount of heat energy which is generated by a circuit or that device, then always apply this formula, that is H is equal to I square RT. What is H? H is the total amount of heat energy which is generated. What is I? I is the electric current, okay, in amperes. R is the resistance and T is the time for which the electric current passes through it. Okay, so this is called as the Joule's law of heating. Okay, it is said that the heat produced in a resistor is directly proportional to the square of current given to the resistor, and directly proportional to the resistance of the given current, and directly proportional to the time for which the current is flowing through the resistor. Okay, so there is a direct relation. H is directly proportional to the square of the electric current. H is directly proportional to the resistance of the conductor. H is directly proportional to the time for which the electric current is flown through this one thing. Okay, so remember this one. Now we are having these different devices like the electric bulb. Okay, in electric bulb, the filament of bulb gives light because the heating effect of the electricity, the filament, you know, that is made up of tungsten, and it has such a great melting point equal to 3380 degrees Celsius. Okay, so that's why we are using this one thing. Similarly, this electric iron is there. Here we are using which one thing? This alloy. Okay, just to increase the resistance of the that material. Okay, and it works with the same mechanism of the electric bulb, right? Now, so one more fact here we are going to discuss, that is the electric fuse. Okay, you are familiar with this electric fuse now. These days at your home you can see that this device is just actually replaced by the MCBs. Okay, but here basic term is which one thing? Electric fuse. It is nothing special, it is just a protective device which used in a circuit, okay, to protect from the overflowing of the electric current. As you know that excessive flow of the electric current may responsible for short circuiting and the which one thing, that is the electric fire. Okay, so the short circuiting and the overloading, if you want to protect from this one, then we have to use a proper strength of electric fuse. Okay, so when there is any short circuit or when there is any overloading, clear, then this excessive flow when passes through this electric fuse, then because of its property it's easily get melted, and its melting is responsible to break the electric circuit. Okay, and this way it will stop the further passing of the electric current, and this way this whole system can be protected. Okay, so for a good electric fuse it should have two property. One thing, it has a good permeability, and second with the low temperature, low which one thing, melting point, low melting point and the higher permeability. If these two properties are there, then it may be a good quality of fuse there. Okay, but just for this one thing you can see that this fuse is of this different value, 1 ampere, 2, 3, 5, 10 ampere. Okay, and this much is basically used for the domestic purposes. Okay, for this one thing, how can we calculate the right fuse for that device? Okay, suppose that if an electric heater consume 1000 watt at the rate of 220 volt. Okay, so you know that I is equal to P upon V. What is the power? 1000. What is the volt? That is the 220. So you just divide this 1000 by 220, then you will get 4.5 ampere. Okay, so if this is the strength of electric current which passes through this one thing, then surely you have to apply an electric fuse of nearly 5 ampere. Okay, so why I am explaining here? Because this type of numerical questions are there in your examination based on this thing. Okay, so learn how to calculate the total strength of this electric fuse, which is more applicable or suitable there only. Clear? Now moving forward for the electric power. What is electric power? It is the amount of electric energy consumed in a circuit per unit time. Okay, remember what is the power, electric power? The total amount of electrical energy consumed by the circuit per unit time, that is called as electric power. Okay, and what is the unit? That is the watt. Again I am telling you, WATT, which is denoted by capital W, and 1 watt is equal to 1 volt into 1 ampere. Okay, that means W is equal to VI. Okay, and 1 kilowatt is equal to 1000 watt. Okay, and the consumption of this electricity is generally measured in kilowatt. Okay, so 1 kilowatt, what you know that what is the professional, or what do you say, the commercial unit of this electricity? That is 1 kilowatt hour. That means how much kilowatt is used in 1 hour, that is equal to 1 unit. Clear? That means if you say that 1 unit is consumed, that means in 1 hour what is the consumption of electricity? 1 kilowatt. Okay, so 1 kilowatt electric current is used in 1 hour, that is equal to 1 kilowatt hour, and this is the domestic unit for the electric charges. Okay, now and remember 1 kilowatt hour is equal to 3.6 into 10 to the power 6 watt second, or you can see that this is 3.6 into 10 to the power 6 joules are there. Okay, so this is all about today's discussion, and I request you, please go through the different numerical which is based on this 1 that is the combination of the resistors. Okay, either which resistors, series arrangement or the parallel arrangement or the mixed arrangement combination. Clear? And next one, that is the heat generated by that system while it is utilized that amount of electric current. Okay, and here is also what electric power is generated by that device. Okay, and what consumption of electricity in manners of the unit. Okay, so please go through these numericals which is given in your exemplar as well as in your book also, textbook also, as well as in your other reference books too. Clear? Just shuffle the last year question papers, surely it will give you the different numbers of the varieties of the numerical which base, and it is damn sure there is a 3-mark question plus 2-mark question is there for this numerical values and the circuits. Okay, so please take care of this one thing, and in excess also learn one more thing, that is the practical or experimental approval or the proof for the verification of Ohm's law. Okay, or you can search this one thing in the form of the verification of Ohm's law in the laboratory. Clear? So just go through it. What are the precautions, the circuit diagram, the observation table. Okay, it may be asked you in your final exams. Clear? So please continue studying and take care of yourself. Thank you. See you later.